Well, good afternoon. This is Comp 422 and Comp 620, despite what the slides say. We're going to talk about SQL injection today, and we're going to talk about steganography, a separate set of slides for that. Our reminder that there's an online quiz out there for number-based conversion. It's been out there for mostly a month. If you haven't done it, and only about a third of the students have done it, you need to get to that. Don't forget it. And remember, it's timed. You have to do it fast. You have to answer the questions because your score is the percent right minus the number of seconds over the limit. And the limit depends on whether you're undergraduate, a certificate student, or a graduate student. So let me know if it doesn't work for you. But and a hint, when you type in the answer in the answer box, you can just press enter. You don't have to use the submit button. It actually is much easier to just press enter. There is a button if you want to press a button. Yes, sir. Oh, there's 20 questions. There's 20 questions. Yes, they're very fast. They're questions like, oh, what is hexadecimal F in binary? And you've got to put, it's 1111, but you have to type that in, press enter, and do that 20 times on an average of 3 seconds, or an average of, whatever it is. Of course, 6 seconds if you're a certificate student, and I suppose that 4 seconds if you're a graduate student. Questions about that? Make sure you get to it. It's due Sunday night, October 1st. Send me an email if you have issues, but I wouldn't wait till Sunday night at 11 o'clock to start it. It is a skill activity. Not only do you have to know the stuff, but you have to be nimble-fingered enough to actually answer it quickly. Yes, question? Oh, yes, you can practice. First of all, I will take your best score, not just your last score or your own. You can do it many, many times. You just, yes, so you can keep doing it over and over again. And if you don't feel like putting your name in, that's okay. It won't. Now you want to put your name in because just by chance, if you do really well, you'd like to get the score, because I'm going to ignore all your attempts except for the very best one. So yes, sir.
So once we get the score on our screen, score automatically goes to you.
It goes to the database that I have.
Oh, it goes to the database.
Yes.
So,
now, if you are an undergraduate student with a 90-second time limit, it will display the score on the screen. But it doesn't know whether you're an undergraduate or a certificate student or a master's. So it just uses the one time. Use some arithmetic. If you get done and you are 20 seconds over, say it takes you, what is it, 110 seconds, which is 20 seconds over 90, but you are a graduate student, then you're in good shape because you're under. By the way, just in case you wonder, no, you don't get any bonus for being faster. It's seconds over, no bonus for being faster than the time limit. Yes. If you want, the answers, by the way, are out on the website. There's a web page that tells you all the hex stuff. And it's been known for students to put up 2 windows on the screen, the quiz and the answers. And that's not really what I want you to do. I want you to know it. Okay. All right. Any questions about that?
Put our name on it each time you attempt, because what I've been doing, I just been like,
again, if you don't put your name on it, I obviously will not know who did it. If you put your name there, I will know, but I ignore bad guesses or slow guesses. I'm going to calculate the score for everyone, take the best entry that you've got, which is not always the last one. Some people try, get a pretty good score, they get 95, they go for 100, and no, it's just not in the fingers. Okay. Let me know if you have any questions. And again, it does take a little finger skill to do it. Okay, yes, question? Right, yeah, yes, if you're, again, although it doesn't display the score, it sends the time and number right up to the server, and then my spreadsheet nicely calculates the scores for everybody. So yes, don't worry about it. It'll only display the scores for the 90-second limit because it doesn't know who you are. But don't worry, if you are a post-baccalaureate certificate student, you get 180 seconds and it will score it appropriately. Okay. And the scores, hopefully if all goes well, if you get it done by midnight, sometime on Monday, I will upload the scores to Blackboard. So you know how you did. Okay. Does anybody online have any questions about this? Hearing none.
Yes,
Oh,
I had a question. Oh, sorry, I had a question. Did you want us to submit like a screenshot of our score to Blackboard?
no. If you do it with your name in it, then it actually sends the score to the server, or it sends the number correct and the time to the server, and then I download that data from the server, which happens to be, by the way, has an SQL database, which we're going to talk about in just a minute. And when I get the data, I then calculate it based on whether you are an undergraduate, graduate, or whatever. Does that answer your question?
Yes, thank you.
All right. Speaking of SQL databases, let's talk about SQL. I'm going to talk a little bit about the SQL language, not because this is a database class, but we're going to talk about a well-known attack on systems that is based on SQL. Okay, structured query language. It's a standardized way of accessing relational databases. Been out there for a long time, since 1970, this fellow Codd. Yes, back in the 70s, I saw a video by Mr. Codd talking about this, but that was a long time ago. Okay, and it basically is excuse me, it is based on tables. Tables have columns and rows. Basically, there's a row of data for every record, and each record has certain columns or certain types of information. There is a structured command line interface for SQL. Here's the most popular command is select. Select means go out and find data that meets a criteria. Well, here's select. This particular type of select meets anything, but you go select, and these are columns. Columns, again, would be like first name, last name, ID, whatever you happen to have in the column from table name. And your table, well, your table needs to have a name in your database, so you go there. Or you can use the star, select star. That means give me everything. Give me all the information from all the columns in that database. And most commonly, you won't see this because that's going to show everything, but you might see where some condition is met, where something is true. So it says selecting columns from table where, let me show you an example. Okay, here's a very simple example using the database table I show here, which is called grades. We'll select F name, comma L name, because F name and L name are columns from grades where, that's supposed to say grade. Well, this won't work because it's got a spelling mistake, but it says grade equals A. And it will return Mary Johnson because Mary Johnson is the only record in the table where grade is equal to A. And then you might say select star from grades where L name equals Smith. And again, it will return one record because there's one record there where the last name is Smith. In this case, because we said star, it returns data from all the columns. Easy enough. There's more, there's an insert. SQL has lots of commands. Some commands to insert data, delete data, update the data, get the data. There's also all sorts of commands for managing the system. Allow access to this, provide this view. This is not a database class, so I'm going to spend like 2 minutes on this, and that's it. Okay. Insert at the table does as you might expect. It puts a row, and then you go value, comma, value, comma, value. By the way, the values are in the order in which the table was created. In other words, in this case, if I create the table with first name, last name, ID, and grade in that order, then it's better to be first name, last name, ID, and grade, and you enter it. Or if you don't want to remember the order, you can always say column name equals the value, comma, so forth. By the way, like so many programming languages, each SQL command ends in a semicolon. I don't know why we write Englishes with periods at the end of the statements instead of semicolons. Okay. And you can update a row, update table name and setting this column value to that where this condition is true. So it's going to go through with wherever that condition is true, it's going to set that column to that particular value. Other ones, you can delete a row from a table or multiple rows. You can say delete from a table where some condition is true, where name equals Williams, or joining tables. That's getting data from multiple tables where certain values, that's a database join. Don't worry about that. There are also some functions. The count function is particularly useful in this case because sometimes you don't want all the records themselves. You just want to know how many are there. How many records met this criteria? Were there 100? Was there 1? Was there 0? And not only can you say equal, but you can say like, and you can give it a template and it'll see, well, is the data something like this? There's this string somewhere in there with a wildcards. And then the magic word null, it's a keyword null, means there's nothing in this field. You can have fields that are empty. Also, in database systems, there are tables about the tables. Yes, the people who build database systems, they have a engine that goes through and works on tables. If you have different users out there, in other words, I use SQL in my Comp 422, Comp 620.online database website. There's a SQL back there, and the database system has a table about the tables that I have, a table about the different databases that are available. So there's tables about tables. Of course, everybody who makes it, and there are multiple vendors of this stuff. Yes, you can get it from MySQL, which is an open, free database system. Oracle's a company that sells databases. Interesting enough, Oracle maintains the MySQL free one. That's kind of conflict with IBM and many other companies sell databases. You can access SQL typing in those commands in many command line systems. And you can also write programs that access it. Programs typically use commands or very much like what you would type in. The select commands and all the others can be entered through a programming interface. So a program can do this. And then the program gets back the results in a table of some kind. So if you want to know all the students who have a grade of A, it will produce a table with that information. The SQL engine, the SQL database, can be on your computer where you're running the program. Or it works very well to have it remotely. You can say, this SQL system is over on that computer, and I'm going to access it, of course, across the network. That's kind of built into SQL, and it works very well. We're talking about this mostly because a lot of systems keep user IDs and passwords in an SQL database. And when they want to know whether you entered a valid user ID and password, it looks them up in the database or looks up the hash in the database. That's why we're here. So let's look at an example. Okay, this example, we're assuming it's running in the server using the PHP language. You don't have to know PHP, it's pretty straightforward. But I'll tell you this, $PHP underscore post underscore vars bracket name. That means I have a web page. And of course, this is our server. You access it through a web page, HTML web page, and it has a little box labeled name. And then when you enter something and press submit, it sends that data that you typed into name over to the server. And this is part of the program says, give me whatever it was in that name field. All PHP variable names start with a $sign. So it's easy to tell where you have a P. So in the variable name, we're going to get whatever the user entered. So that's the web interface. So all you need to know right now about a web interface is that a PHP program can get it with this, giving it that name. Okay, so now we've got the name. And then we're going to concatenate that name in with a SQL select statement. So select star from restaurants where name equals quote, because the string has to be in single quotes. Then concatenate it. Period is the concatenate operator in PHP, which I find really annoying because often when you're writing web-based applications, you're writing a PHP program on the server and a JavaScript program for HTML, and JavaScript uses a plus to concatenate and PHP uses a period to concatenate. I can't tell you how many times I've screwed them up. Okay, but besides that, yes. So this is going to concatenate the dollar name variable. Now you might note the quotes very carefully. There is a single quote, which is part of the string here. And then this double quote ends this double quote. So it goes select quote from, excuse me, select star from restaurants where name equals single quote. That's a character string. Then we concatenate that with the name and end it with a single quote. So there will be single quotes on either side of the name, which it needs because this is data value. The name is going to be a data. And it may have a blank in it. Say you're looking for O. Henry or something where there might be a space. O. Henry's bad because it has a quote, but no one. All right, then once you got it, you pass it to the SQL system saying, here's a query, here's a string, it does it and returns the result in some format that we won't discuss at this time. All right, so here's a bigger login. We go out, we get the name, which was entered in a HTML web page, form. This one will have both the user ID and password, your typical login screen. And we get those in the variables. We create the select statement where login, where username equals quote, put the name in there, and the password equals that, put the name in quote. Give that to SQL, and the answer is results. Results is a table sort of data structure. And then there's the num rows parameter of this data structure. Well, how many rows do we get? If we got something more than 0, we allow it. Because if you got 0, it means there was not a row in that database with that name and that password. So SQL has already checked your password for you? No. And of course, by the way, this password, it shows it here as being just a straight password. It could be the hash of the password. Normally is. And if it finds something, you go, oh, we found it. There is a data value active, that user ID and password. Let them in. And so it typed in my name, select star from login where username equals quote can W and password equals quote secret. And if that's true, if there is a username and with that password, well, let's them in. So far, so good. Now comes the evil stuff. There's a SQL injection threat that can be done. This is where users don't enter something nice and friendly when you ask them to. All right, we're going to do the usual, select this where user ID, blah, blah, blah. Okay, but instead of entering the password, we enter X single quote or quote A, quote equals quote A, no end quote. Got to watch your quotes. In this stuff, the quotes are very important. And so when they mash this together, they concatenate the variables and the SQL statement, you get select star for login where username equals Alice and password equals quote X quote or quote A quote equals quote A quote. The first quote there was part of this, but we provide another quote and the last quote there. So we get this. Now there's an or in there. Remember how logical conjunctions work? If you have A or B, if A is true, the whole statement is true. If they're both true, the whole statement, only when both statements are false. A equals A is always true. A does always equal A. So A equals A is always true. And since it's always true, it doesn't matter if password equals X or Alice, because A equals A, that's true. And so it's going to select all those. So if you go back here and you say, well, did I get something? Oh, yeah, not only did you get something, you got the whole database. And so it's going to say, let them in. Yes, in other words, we didn't enter here, but there was originally, we see we're going to take this string we entered and stick it in here where it says $password. There is an end quote. Yes, so the end, oh, you are correct. Somebody who wrote these slides obviously didn't have it, because I got my crayons out this morning, was changing the colors of these things. I didn't get them all. Well, I thought it looked better than all black. Okay, yes, I think I missed a couple others too. So keep looking. All right. So that's it. Again, you have to watch your punctuation. Punctuation is challenging when you're doing an SQL injection attack. Look at another example. Here we're going to go select count. Again, count star. Instead of returning all the rows, just tell me how many there were. And for most logins, you're going to say, well, did I get 0 or something? You know, you're expecting 1 or 0. Okay, same thing. We're going to do that. And then instead of just entering the password, we go X quote semicolon, because like Java and C and many other languages, the semicolon ends the statement, and then it continues on. You go insert into login, set username equals me, password equals my secret. No quote there because the quote there is going to fit into it. But what happens is you end up with the select statement where password equals X. Well, that's not going to work, but the next statement will work. Insert into login, set username, that, and password. So now you have added a new user ID and password into the database. Got the quote, the correct color too, you might notice. Yes, so worse than faking somebody's password, we've added a user ID. Typically, most systems don't know what users are out there. It's in their data, it's in their database file, what users and what passwords. So if you add one, it must be true because it's there. Here's another example. Again, we're doing it with the count. And we're going to go X quote, so that's going to be password, and then semicolon, update, login, set password equals my secret or username equals admin. So what you're doing, you're assuming that there is a user called admin, and now you're changing their password. So the admin is going to be a little upset because they won't be able to log in, which makes it somewhat difficult. If they think you're doing something nasty and they want to go out there and try to fix it, they can't log in. But you can. You can log in as admin, which is usually pretty powerful. Okay. Like many programming languages, SQL statements end in a semicolon. They also use dash, two minus signs to start a comment. I know most of you are usual, like Java, C++ uses // No, this uses dash. So dash starts comes. Anything after that is ignored, which is useful when you're trying to attack these things, because if you put dashes out there, you don't have to worry about the rest of it. It's just going to figure it out. Okay, so here, let's take a look at this one. And the attacker enters whatever, quote, or 1 equals 1, semicolon, dash. So this ends up being, when it's concatenated together, where user is whatever, quote, or 1 equals 1. And of course, 1 does equal 1, so it's true. Semicolon, dash. This and password doesn't matter what that is, because that's just part of a comment. It's not going to interpret that. End of the statement in semicolon. Good enough. Everybody ready to go out and attack systems viciously? Let's see how you do with this poll. So for those online people, you will see a generic question. I bet that the Zoom system uses SQL databases to keep the polls. Because when I tried to put in things with like a quote, semicolon, it goes, oh no, you can't do that. if I left off the special characters, it didn't care. It let me put in these, but putting those things in there, it goes, oh, no, it gave me an error when I tried to create the question. So I'm pretty sure. I didn't try to attack Zoom. I was just trying to put in questions that had answers. Oh, yes. Anybody here need a card? Oh. Okay, let's go. Those things don't fly from. All right. Okay. Okay, display the question. Okay, there we go. All right, hold up without your fingers in front of it. All right, got those, got. I get your finger. Oh, yeah, it's really thick. You got to see the whole thing. There you go. Pretty impressed with the resolutions. I can't see. All right, we have a. Well, let's see. People online like B. It's in the poll. Share the results. In class, B or C are the popular answers. No, it's not C. It's B. B is the correct answer here, because when you concatenate them together, yes, it's going to be password. Yes, the quote password is password equals B semicolon drop table login. See the dash dash. The dash dash, of course, is a comment, so the rest of it will be ignored. Right? B is the password guess. Got that? Does that make sense? Okay. A question about this question. Yes, drop table is an SQL statement. Yes. Go back to the XKCD cartoon, the very first slide. Yes. Yeah, it's in there. Okay, yes. But this is not a database class. But you should know that one. All right. Why does this happen? Well, it's not really a weakness in SQL. It's a weakness in how people use SQL. I also point out that when you run a program on a server that responds to web input, that program usually runs under a particular user ID and with a password. In fact, when the program starts and you're going to access the database, you have to give it a user ID and password. Don't run it as root. Don't run it as admin. Don't give it privileges it doesn't need. Talk about that in a minute. But the big problem is that you are using untrusted data, using user input, and you're going to interpret it. You're going to concatenate it into a string that the SQL language will then interpret, and that's the root of the problem. This is a real problem. It's one of the really nasty errors out there. If you go out to the OWASP.org website, OWASP is a website with lots of security information about it. They have the top 10. This always comes in the top 10 hazards. This is several years ago. Oh, wow, that's like 15 years ago. Okay, so I'm old. But yes, they attacked it and got lots of stuff. All right, this question is not a question about the class. It's a question about other classes. You don't have to think hard about it. You either took the class and try to remember, or don't remember, you can always.
There you go, all gotcha.
Okay, all right. Here, we can end the poll, show the results. There's a couple of people who've never taken a database class, but not too many. Not more than standing here. Some people, but a majority of people, particularly online, majority of the people were not taught a secure way. So I'm going to go over how to do it securely. And then I'm going to go back and hassle the people who teach database here on campus. And I think this semester it's Dr. Hinton. I've already talked to Dr. Hinton about it. But okay. Yes, it's important to do it. And I know a lot of instructors only teach it the insecure way. And I wish they would stop doing that. All right, back. Stop sharing. Okay, again, we talked about hashing the passwords. Instead of keeping the original passwords out there, put a SH1, A1, SHA25, whatever hash you happen to like. And when the password comes in, you hash it, you compare it to the hash in the database and see if they were easy enough. That way, if somebody again gets your database file or is clever enough to get all the information out of your database, they'll just get the passwords, which are very hard to go back. And if people have used strong passwords, then it would be very difficult for them to to figure out what the hash is. If they use common passwords, then a dictionary attack will get them. If they don't, they're safe. Okay, so basically what you've got is a program HTML web page with fields in it. You enter the fields, you press the submit button. It sends it to an application on the server, which then accesses a database. There is of course, you're running on your computer with the browser. There's a program running on the server, which then accesses the database through a database management system. One of the big rules in computing is the principle of least privilege, which says give a user or a program only enough access necessary to accomplish the task. That is a basic rule in all the security stuff. Don't give people, programs, humans, more access rights, more authority than they need. Because if they only have enough access to do what they have to do, then they can't do other things. For instance, if all you're doing is looking up user IDs and passwords in the database, and you're not changing passwords, all you do is looking them up, and all you need is read access to that database. In fact, only that database, turns out that SQL has all sorts of access restrictions that you can apply that most people don't know about, but you can do these access restrictions so the user that's running the web page can only read that database. So they're very limited. They can't make a mess. They can't delete it. They can't do that drop table thing because that's not in there. Okay, again, like I said that. Now, it's very easy on our examples here because I showed you the SQL command that's going to be executed. What if you don't know the SQL command? What if you don't know the database? Well, you can figure it out. Even nastier, there are tools that'll help you figure it out. Okay, go to and here. And email equals null. Well, if email doesn't exist, you're going to get an error message. This to be, if email exists and it's not null, it's true or it's true or false, that'll be okay. But if email does exist, then it's a syntax error in the SQL command. You've accessed a column name that's incorrect, it's not in that table, and it'll get an error. You'll probably get an error back when you do it. You keep guessing until you get one that works, or you get a different kind of error. Maybe it doesn't match, but you now know what the name is. So you try it, you try it, you try it until you find one that works. And you can guess other things. You can guess other table names. Guess, does it exist in other tables? So, yes, anyway, it's not hard. Particularly if you think about a program that goes out there and tries multiple times, you can go out there, have a list of you think it's going to have email addresses, or name that they're likely to use, because most databases use names that humans made up because the database administrator, wanted something that he would understand or she would understand. So what do you do about this? One thing you can do that helps a lot is to check the input. Check that the input is reasonable, that you don't put nasty characters in there. Excuse me. Now, if you're doing this, it's generally better to look for good characters than try to look for bad characters. In other words, if the input contains these characters and nothing else, then you accept it. If there's a character that's not in your list of nice characters, done. That's not always as easy as you want if you're going to allow arbitrary text, particularly if you're adding usernames. If the usernames are regular user IDs or email addresses, fine, you can handle that. If you're asking for people's names or something, sometimes people's names have spaces. Some have like O Malley or O Henry, where people put an O quote Henry. Okay. Hey, looking for quotes because you think, let's look for a quote because that seems to be one of the things we have in all these. Well, you can do an encapsulation and escape characters, %27, where 27 happens to be the hexadecimal representation of the single quote character. So %27 is acceptable, and that will translate to a quote. But in the input string, it will be %27. And if you search for quotes, you're not going to see it. And it gets even more challenging if you're doing this with other character sets. If it's coming in some Unicode character set, and you've got all sorts of languages besides English, you've got characters with accents, you've got Japanese and Chinese and Arabic and all sorts of character sets that make it challenging. Is that a question? Is that a question? No. Okay. All right. So that's something to think about there. Also, if it's numerical values, you don't need quotes at all. Let's look at this one, where the IDs are numerical, where ID equals 23, or 1 equals 1. They didn't expect quotes. They were looking for numerical values. Numerical values don't have to have quotes around them. They are numbers. SQL requires quotes around a character string, but not around numbers, because numbers are numbers and you can understand the number. So here, you don't need quotes at all. And of course, 1 equals 1 is an always true statement, so it'll always match. How do you fix this? Here is the best way to fix this. And if you're ever out there writing a program that accesses an SQL database, do this. Okay. First of all, you got to create a database object. There's a MySQLi and a bunch of parameters. Parameters include things like username, password, database, and stuff like that. And put it into $goat. If anybody's ever had me for other classes, when you use programming names, I like to use animals because there is no $goat keyword in PHP or dog or cat. So when you see an animal, that's a variable name I put in there. In fact, some student said they were looking forward to animals. So here it is, folks. There's goat. So $dog is this string that has question marks in there where we expect to put the values. And then we're going to go prepare this. So we tell SQL that here's the statement we're coming up, we're going to use it. So $cat is the prepared version of that statement. And then we say we want to bind parameters. SS means the first question mark is going to be replaced by a string that's in the variable $student. The second question mark will be replaced with a string that's in the variable $class. And so it's going to execute the statement, but it's not going to interpret the string. It's going to use the data values as data values. In other words, it's never going to concatenate this thing together. And then you can execute it and get the results back. This is much, much safer because, again, we're not concatenating user information, user entered values into a string that's going to be interpreted. this $dog string is going to be interpreted, and it's clean. It looks good. And then the data that you use will be used as data. So if you put some sort of SQL attack in there, it's just going to put X quote or 1 equals 1 into the database as the value. And it's not going to cause trouble. Now, I might point out here that when you write this, these things all, every time you call one of these functions, they return a potential error message or error, and you should check that. I had to say this, underline, bold, in red. For all those who write programs, always check for errors. If this function will throw an exception, if it would turn a bad error code, check for it. I can't tell you how many student programs I've seen where they're calling a function, it returns an error code, but they don't check the error code. It just keeps on going, and they think the program works fine because they don't see any errors. Or I've had them, grad students no less, where they have a throw catch block, and a catch block has nothing, just empty curly brackets, and it doesn't do anything. And they think the program works because they don't see any errors. Of course not. They suppressed all the errors. So always look for errors. Here's an example. So back up here, where we're doing the prepare, instead of just that one statement, there is the prepare statement inside an if, because it's going to return true or false if it worked or not. If it doesn't work, it's going to be false. There's an exclamation point, was the not, like in many other languages. So if it's not true, if it's false, then you can execute the die statement. That says, terminate this program, send back an error message to the HTML, back to the browser. We're done. This has failed. And you can tell it, you can send it a text message. In this case, the text message is going to be star error star, and then I concatenate the error number and the error text. So program will get that. Mind you, by the way, you don't always want to tell the users exactly what the error is, because that may be too much information for them to know. Again, using parameterized SQL. And there's other ways to do it safely. This is one way. I think to me, it's the easiest way. The user input is never interpreted. It interprets the select statement with the question marks, but nothing else. Everything else is just data. It is not more difficult than concatenating them together. It does take a couple more lines, 2 or 3 more lines, but it's much more secure. Also, if you had to be using SQL statement multiple times, once you prepare it once, you can go out there and execute it many times, and it will run much faster because it doesn't have to interpret the statement multiple times. So it's better performance. So never, ever concatenate user data to make anything that's executed. In this case, database query, or we'll see it other places. This is a true sin, is to concatenate user data in with a statement that's going to be executed, because several of the attacks we're going to show this semester are where you put clever user data in there, where user expected a nice happy name. No, you give them an executable statement and the system executes it. Might note a couple of things. MySQL, which is the free and very commonly used SQL system, is commonly used because it's free. I mean, a lot of corporations use it because they like the word free. And it doesn't allow multiple. In other words, you can't put multiple statements. You can also, if you want to, omit the semicolon, and it doesn't care. It doesn't give you an error. Like I mentioned, limit the privileges of the application. Don't give it everything. Don't run as root. You can check if you expect the user to enter an 8-digit username. Don't allow inputs more than 8 digits. And in production systems, do not display error messages that give away too much information. If you use Apache SQL system, or not SQL, Apache database server, or not a database server, excuse me, HTML server, it's a web server. It's a commonly used one. If you use that, there are flags you can set, configurations that say, should you show the error messages or should you not show the error messages? And of course, when you're doing development, show detailed error messages so you know what the blazes is going on. But once you get it working, turn off those error messages. It's really easy. Just go into actually click that box and now they won't see it. All right, let's try this. Good. It's not pure. Oh. Okay. Show us a guess. Well, okay. Is it? Yeah. Okay. And B is very popular on online and here in class, which is nice because B is the way to sanitize you. Sanitizing user input means looking at it, making sure it has only good characters, is in the proper form that you expect the user to enter. It doesn't contain nasty things that will cause an SQL injection. Okay. Oh, and only accessing the database's root. That's yeah, don't do that. That's terrible. All right. Blind SQL injection. I think I mentioned it before. Putting in statements that are true or false, looking for the structure of the database. Keep putting in things that are come out true or false. You get different types of errors until you get. There are automated tools to do this. Interesting enough, you can look for a username because you can say, well, there's only 26 letters in the alphabet. You can say, there's it greater than whatever the middle letter is, K or something. Is it greater than K? Yes. Okay, then you just start narrowing it down. Binary search, log base 2 of 26 to get you done in 7 requests. If there's 8 characters in it, 7 times 8 is 50. In 56 requests, you can figure out what the username is. Not that hard. And so, and again, if it takes 10 seconds to make each request, you're doing it by hand. You do it in 80 seconds. It takes less than 10, just over 10 minutes. Of course, you have a tool, seconds. All right, any questions? Go back to our, now you understand what we're doing here. Well, if you can see that, I don't know if I can see it. Anyway, okay, let's switch over to a different topic. Okay. Online, can you see the quote, a picture can hide as much as it reveals?
Yes.
Thank you.
Yes.
All right, we're on. We're running. We're going to talk about steganography the next 25 minutes or so. Yes. Several students have mentioned steganography in some of their answers in some places. I thought I'd talk about it. It's not mentioned in the book, but I also think it's kind of fun. So we will talk about it today. Steganography is hiding messages. We talk about encrypting so people can see the message. They just can't figure out what it means. Steganography is hiding it someplace, putting it somewhere where others won't find it. Now, this is sort of a way of security through obscurity, which I hopefully we mentioned earlier is a really bad way to keep things hidden, or actually keep things secure. Hiding is not real good. But if you're trying to get a message from one place to another, sometimes you can do it by hiding the message. Way back, 1883, this fellow Kirchhoff says crypto systems should be secure if you know everything about it, except the key. Even if you know all that sort of stuff, should still be secure. And that, of course, applies today. We have public, well-known encryption algorithms that everybody uses. It's just you have to know the key to break it. Claude Shannon, who is he did a bunch of compression, transmissions, he did a bunch of stuff, electrical engineer, an interesting person. Anyway, he said the enemy knows the system. And of course, steganography is pretty much a security through obscurity, that you're hiding things. And you're hoping that the other people don't know how you're hiding things. It's been around for a long time, way back. The end of the 15th century, this fellow wrote a book on steganography. But he used steganography to hide it. He disguised it as a book of magic. But if you knew how the message was in it, it was a book about steganography where he used steganography to hide it. Catholic Church didn't like this. They put his book on the Index Liborium Prohibitum, which is a list of books that good Catholics should not read. But I think actually the Index of Liborium got dissolved sometime the later part of the 20th century, but it was around for a long time. Anyway, yes, so he had this book and talks about encryption keys. A book is about steganography. Now, you can also do steganography digitally. You can do it physically. People have done ways of hiding messages for thousands of years. A fun one I like is you take a piece of yarn and you color it in Morse code. So you have a dash, space, a dot, space, a dash, and so forth, and you write the message out on the yarn. And then you knit the yarn into something, and you have your courier take the wear the something when they go over to the side. People, please look at the yarn, look at your clothing. It's got multicolored pattern, but doesn't it? What can they tell? Particularly if it's all knitted together, it's hard to see the whole yarn. They get to the other side, the person unstrings the knitting and looks at the Morse code and figures out what the message is. Another one from thousands of years ago, that you shave your courier's head, tattoo the message on top of their head, let the hair grow back, and send them across enemy lines to get to the other side, where they shave their head to read the message. Okay, people have used invisible ink for a long time. If you're a kid, you probably tried lemon juice on paper. It works pretty well. You heat it up, you can see it. Then write small messages under the postage stamp. I like that one. Okay, here's another tricky one. I think I stole this from Wikipedia, but you have text. And text is but every now and again, the tail of the character goes up. You can see that this, if you look, well, I can see, it's probably hard to see, but like the G goes up, the N it goes up, otherwise to connect it. And then you count the number of characters between when it goes up, and that gives you a string of numbers. And then you use that numbers represents an encryption, and you can run that through some government system and figure out what in fact they're trying to tell you. Now you can use steganography and encryption. You can hide an encrypted message. So even if the opposing side finds out how you're hiding your message, they then have to decrypt it, which might be very difficult. Sometimes you don't want other people to even know you're sending messages. Let them know you don't want them to know the contents of the message. You don't want them to know you're even sending a message. So that's where steganography comes. So you encrypt the message and then you hide it. There are multiple ways. There's been people have hidden malware in other files. So people download the files, and it's inside the malware is, inside the innocent file is nasty stuff. You can even have it comes in pairs of files. This Lokibot has an image, some sort of picture, and inside the picture is some data. And then in a Microsoft Office document like Microsoft Word, which can run scripts, you could have a script or a macros for the Microsoft document. When you open up, it executes the macro. There's an on open macro. When it executes that, it goes out to the file with the picture, which ought to be there, and does nasty stuff. You can put the information anywhere. In HTML, there's all sorts of comments. You don't have, in other words, the comments are not displayed. There's all sorts of markup that isn't displayed. You can put the secret message in there as comments. So a user who looks at the web page sees what's supposed to be displayed and looks innocent enough. But if you look at the source of the web page, you see the comments, you go, oh, there's the secret message. Not very technical at all, but it would work. Also, I saw this one where there are non-printing characters out there, particularly in Unicode. There's a couple of them. You can use those non-printing characters as zeros and ones. You put a zero with joiner and a zero with non-joiner out there. A zero with joiner is a zero. The non-joiner is a one. You sprinkle those out in your text, and they don't show in the text at all because they're non-display. But if you go back and look at the text with a program that analyzes these characters, you'll find them and you can decipher the message. It's always fun to put the pictures into images. Well, excuse me, not put the pictures in, put the hidden text into images. There's many ways you do that. I'm going to talk about that in a minute. This little picture here has text. I hid it myself. There's a bunch of text inside that file. That's a PNG file. Yeah, PNG is interesting because PNG has information, what they call chunks. A chunk has a header, which contains the chunk label, the length, a checksum to make sure that it's correct. And you can create new ones. That allows it to be upward compatible, because if you have an older version of a graphics program displaying PNGs, and it comes across a new file with a chunk type that it doesn't recognize, it just ignores it. So you can create a chunk type of your own, which I did, and put it in the file with proper length and proper checksum. And there it is. If you look at it as a binary file, or if you just display the hexadecimal text or the character text of the file, you can see the message, but it's not displayed in the image at all. Of course, you can display it in the image. This is a picture I got from Wikipedia. Here is the original image that you see when you look at it. But you go out and you start massaging the bits. In fact, I have, when I taught Comp 160 or GEN 160, I had a program where students would go out and massage the bits of a picture and get a different picture. But here it's done, and you take and you remove everything with the last two bits of each color. And then it's dark, but you enhance the intensity and you get the picture of the cat. So in fact, you don't see the cat in here at all, but it is there. It's hiding. Real quickly, let me go through graphics files. This is not really part of the class, but it's just information. It's kind of necessary to talk about some stuff. Okay, basically graphics come in two formats: vectors and raster. A vector is when you say, starting at this location, draw a line to that location, or starting at this location, draw a circle or an arc of a circle with this radius at this center. And basically it has, usually circles or parts of circles and a line. That's the choices you have. And it draws it from point A to B. Raster, on the other hand, is you look at the screen as a bunch of dots, and then it just sets each dot to a particular color. Each dot, by the way, is called a pixel on your screen. This brings around the second question, which I didn't talk about, but let's just see if you know. Okay, real quick.
Come on. All right, there we go. Oh, wrong mic. I got you. Oh, your finger over. There we go. That's it.
Okay. Uh, oh, vector seems really popular. Too bad. It's raster. Yes, when you have your screen here on your computer or on here, I look real closely up here. I can see little dots. Yes, it's pixels. All your computer screens, your phones, all work on rasters. They have little pixels. They set the pixels to color. I remember using an engineering drafting system that used vectors, and it would record the lines. And yes. Now, if you go out to Wikipedia, Wikipedia likes vector files. Vector files is SVG extension, something vector graphics, and it converts it to, your system converts it to raster to show on the screen. So yeah, what's the right answer? Oh, I don't know. I was thinking raster, but some people use it. Whatever. That's not important. But the big thing is most of your screens, your phones, your computers are raster. The little dots. And again, you can check the screen resolution. You go out, you right-click the background of your screen and look at properties. It tells you how many pixels across, how many pixels high. Generally, you have about 90 pixels per inch on a screen. Actually, you have more on your phone usually because your phone being small, you have to look at it carefully. You want to see more detail. Big screen, you don't have to look at it too closely. Okay. Printers. Your typical laser printer does 600 to 1200 pixels per inch, better than your screen. You get a pixel. Pixel is a picture element. It has color. If it's monochrome picture, it's just black and white. There's only two colors. Typically, colors are represented by some mixture of the three primary colors, red, green, and blue. And you might also have an intensity number. How intense is that? If it's a black and white picture, well, each pixel only needs 1 bit. Easy enough. If you're doing full color, then there are red, green, blue, three colors. They're each represented by an 8-bit byte. So 3 times 8 is 24 bits. Other simpler graphic systems might use fewer numbers of colors. There are all sorts of graphic formats out there. Let me go quickly over BMP bitmap file. Bitmap file. It takes each pixel and represents it either in color or black and white or whatever color system you're using. It takes a lot of space because if you have a full color image, then it's going to take 24, maybe 32 bits per pixel. And so if you have 1,000 by 1,000 picture, that's a lot of data. There is no compression to it. People like to compress things these days. On the other hand, no matter how complex the image, it stores it without any information lost. PNG is somewhat similar. It replaces GIF or GIF files. GIF files aren't used too much anymore because this company Unisys said, oh, we have the patent on that. You're going to use it, you have to pay us. And everybody said, oh, no, I don't want to pay you to do that. So they jumped over to this new system, PNG. PNG is somewhat similar to BMP. It records every bit. It does do compression, but it does a lossless compression. No information is lost. So if you store something as a PNG, it'll shrink it. The file size will be much smaller than a BMP and not having data loss. That's opposed to JPEG. JPEG will compress it and it's a lossy compression. In other words, there will be some data loss. On the other hand, it compresses very well. Typically, by the way, if you are using a zip compression or something, don't bother trying to compress JPEG files or PNG files because they're already compressed. And if you try to compress them, they generally do not compress very well at all. I think I showed these pictures before. JPEG has a quality image, so you can specify the quality and how much compression you want. This particular image took about 220 bytes, 220,000 bytes in the BMP. The JPEG was 37% of that. But if you download the quality, here's the quality is 50%. I cannot tell any difference between 150 and now it's only 6%. Then it gets smaller. Eventually, though, the quality starts to get kind of poor until you get really down to miserable quality. JPEG, it's probably hard for you to see this on the screen. If you go out and look carefully at the slides, there are dots out here around the letters. JPEG has this issue. If you have text, it was not intended to store text. It's intended to store images, photographs. It's a photograph compression system. In photographs, the real world doesn't have lots of lines like that. So you can use BMP, they're big. JPEG works great for photographs, if though it's a computer-generated image. If you have an image that you created that has text in it or something, PNG works really well. I think a lot of systems, I think Microsoft nowadays defaults to PNG for most images, because JPEG will introduce these dots. Now, how do you hide this? The trick is to take some bits of the picture, often the least significant bits, and change those. So they are not, so even though they're part of the picture, you change those bits, maybe one bit, maybe a couple bits, to what the image is. So not the image, the text, the hidden information that you're sending is represented by the least significant bit. Very hard to tell as a human being. Besides, say you're going to set it to using one bit. Now, 50% of the time, the hidden text is going to be, was the bit that the message is going to be. So, if the color picture has a 50% chance that that bit is going to be a 1, and the text has a 50% chance, you have a 50% chance it's going to happen. Here's another question, just to see if people are paying attention. There we go. Oh, hang on, this is not working. What do you mean it's not working? Can you see the best bits message online?
We can see the question, but
You
we
don't
can't
see
see
poll.
the
You don't see
answer.
the poll. What's the matter with this poll? Okay. Well. Oh, okay. There we go. Now you should see it. Okay. Okay, you had enough time to figure out this one while I fumbled around with the computer. I gotta see it. Okay, phone's gonna see it. All right. Oh, all right. Hey, is it overwhelming? What are the best bits to use? You want most significant bits? Ah, come on, folks, the least significant bits. The most, if you look at a number, let's look at a 4-bit number. It goes from 0 up to 15, right? If you have the number 10, which is 1010, and you change the most significant bit, which is that leading 1, then it becomes 0010, which is 2. If you change the least significant bit, which is the rightmost, then it becomes 1011, which is 11. You change it only from 10 to 11, a little small change. You want to change the least significant bit. So changing the least significant bit is very hard to tell because you have 256 possible values. So you're making a change, which is basically a 1 in 256 possible change. Let's look at some examples here. Oh, stop sharing this. And make it go away. And here is a picture of a dinosaur. Here is the original image. Here it is with the syllabus for this course hidden in it. Do you see any difference? I don't see any difference between it. I'm using only 1 bit. I'm taking that 8-bit blue value because remember there's red, green, blue. And so there's 24 bits. I'm changing only the blue byte, the least significant bit. I'm changing that. So then if I pull it out of the picture. And I wrote a program that reads in the picture file, pulls out the least significant bit of all of the blue for each pixels, and puts it together, concatenates it together, and you get the text, or put it out there, or you can write it out there, pull back in. Can't see it. I found, in fact, if you up it to 8 bits per pixel, that I used, I think, 3 bits, 2 bits in the color. Still, you can hardly tell any difference between this one and that one. The dinosaur. Oh, what kind of dinosaur is that? It's a Stegosaurus for steganography, of course. All right, I couldn't help it. All right, I did. Here is a very simple picture, and looking at it, if you look really, really closely, you can start to see some dots in here, because in the white, you start to notice, because I put 8 bits, we start to changing the color a little bit. Now, there are uses, real, honest, legitimate uses for steganography. Watermarking is the big one. Watermarking is putting a image or some seal on the picture to identify it. You often use for copyrights. I put the some sort of seal. Often you can see them. You can see, if you go out to Google and you look at the maps or at the street view, somewhere, if you look very carefully in the background, you'll see it says copyright Google. It's faint, but it's there. They don't want to get in the way. But if you start copying that picture and selling it, they go, hey, that's ours. I know it's ours, but you can see it. You can also, of course, hide it. We now know about steganography. You can hide your copyright image in there, and then people will know it. It's interesting, I thought, that some brands of color printers print some tiny yellow dots in margin of what you're printing. And the yellow dots tell you the serial number of the printer that you're using and when you did it, time and date. The FBI knows all about that. So you know whose printer it is. Remember we talked about chaffing and winnowing, where you send messages with a bit at a time with a message authentication code that tells you whether it's been. You can do that along with, that is sort of a steganography issue. You send off bits, and some of them are good, some are bad. You can't tell. And if you combine that, hiding it someplace, boy, it's really hard to tell because there are bits out there. You can do it in pictures. You can do it in text. You can do it in audio recordings, sound recordings. You can, a couple ways you can do this. Like PNG, I mentioned there's chunks in the file. Most of your audio files have chunks, and you can just hide the text in the file, and it won't be interpreted by the sound player. Or you can put it in there as certain sounds, and then you can separate out by frequencies and hear the different sounds. You have a faint sound at a high frequency. You can, it's very easy to separate that out, and then you can get the message at that frequency. Videos. Video is very much like still pictures, but you have like 24 pictures a second, so you have lots of images you can place to hide things. You can also hide things in transmission messages. In some of the transmission formats, like IP or TCP, there are some fields that have unused bits. You can use those bits. You can put a bit in there, so every time the packet is sent across, you can have the bit there or not and send a message in that. Now, it's kind of slow transmission because you may be sending 1 bit per packet, but that may be plenty good to get a message through. On the other hand, in order to do that, you have to have low-level access. You have to be able to see the packets, not just what we see at the user end. Yes? Oh, yeah, well, yes, this song is evil because they have, some message from the devil if you play it backwards. Yeah. Yes, that's usually hard to accomplish, but yes, any way you can hide it. That's been done. Those of you who've ever used a vinyl album, a disc about 12 inches across, black vinyl with a groove in it, these songs are separated by empty space, and you can usually see them on the disk because they're not as compact as they are normally are. People have put things in the space. Okay. Okay, stick analysis. Well, it's hard to recognize. Sometimes you can do statistical analysis on the bits. If you have a color picture, the bits are going to vary in a more predictable way. If they don't vary in that way, if they seem to be sort of random, you might have somebody hiding a message on you. Now, if you have lossy compression, that may not, the information may not go through if you have an image. There are tools to do this. Go out to Wikipedia, look at steganography. I found 23 tools that will hide things for you. You don't have to write the program yourself. It will do it. Yes, this has got the first page of the syllabus in it. Looks just like that one. I can't tell. It's because the human eye is very accepting of minor differences. And once you get to be an old guy like me, you can't tell the difference in that one. There are things you can do. One of the interesting things is you look at a picture. Instead of taking the file, take a screenshot of what you see and convert it back to an image. That's enough processing that you'll probably lose anything hidden in it. Okay, that's it for today. Reminder, Sunday at midnight, this assignment is due. Don't wait till just before midnight because it does take time. I told you about this almost a month ago. Only about only about a third of you have done it. Get out there and do it. It counts as a quiz. It counts as other quizzes we've done. Don't miss it. It takes some manual skill to do it. So, and you can do it as often as you like. I take your best score. So do it. And even if you get a score you like, you can keep trying to get better scores. I will take your very best score. You have to put your name in the field. Oh, and a trick, by the way, type your guess inside the field. Instead of pressing the submit key, just press enter. It'll take it. The time limit varies depending on how you're registered for the class. Undergrads get 90 seconds because I figure they're young and their fingers are fast. These poor certificate students are getting older and they're getting slower. So you got twice as much time. And graduate students are somewhere in the middle. Okay, let me know if you have problems. Question?
So I'm in Comp 6 when I get 126. So let's say I completed in 136. It'll take off
10 points. Yes, that is a student who's a graduate student gets 120 seconds. They do it in 130 seconds. Say they get them all right. But they're 10 seconds over, so they get a score 90. Another question. Oh, I keep them small. I think all the binary things are less than F. Except for, I think there's one exception that's a big number that you ought to know. There's no difficult ones beyond small numbers. Yes, sir. There's 20 questions. They're randomly selected. They're different every time you do it. Excuse me? Yes, you can again do this as often as you like. You can sit there and keep doing it until you get the grade you like. I recommend you do. Because remember, it is a score, it is count. Okay, that's it. I have to go home. It's a big day for me, so see you. Okay.